All right, students. Hey, great day. Mr. McCrae here. This is our problem of the day, week 4 cheat sheet. Um, so what we had is a problem involving us starting at 48, getting to our vertex and hitting the ground right about 5.5. And I ask you to fill in these word bubbles. I'm going to ask you, if you haven't done so, to turn the video off about 30 seconds, fill these word bubbles in, come back to me because I want to talk about 1, 2, and 3. So go ahead and turn off the video. Come back. Okay, class, welcome back. Hopefully you were able to fill in my word bubbles and know what I was looking for is our initial value is always identified as our y-intercept. Here are coordinates 0, 48. The top of every parabola or the bottom of every parabola, max and min, is our vertex. Sometimes I call it the turning point. If you took a look at the coordinates, it's 2.5, comma 150. And it's also worth knowing that when someone's asked about the axis of symmetry in the past, I would say take a look at the x of the vertex. In this case, the axis of symmetry would be 2.5. And finally, when we hit the ground, we're looking at our AKA our roots or our zeros or our x-intercepts. 5.5 comma 0 would give you that. Okay? So the next question. Example 2. We got a rock, and this rock hits the ground. And we know it starts here, and a little ways that we get to our highest value, and then a little ways more, it hits the ground. But we don't know when it hits the ground. What we're left with is this set of questions. And we need to remember that when we get something that resembles this, not. Based on the data, which statement is not valid? That means that we're looking for, instead of looking for a true statement, we're looking for a false statement. Take a moment with your buddies and think about that and come back to me when you have that. All right, welcome back. Hey, a little bit of an oversight for example 1. We didn't answer the questions 1, 2, or 3, and let's kind of do that now. So where we're starting is the ball is thrown from the y-intercept. That's 48 feet above ground. How long does it take to hit the ground? Well, look at the x-intercept. That's 5.5 seconds. When are we increasing? Well, we know that we're increasing in between our beginning and in between our vertex. So that would be 0 to 2.5. Okay, and now we are ready here. All right, so again, I said which statements would not be true. Only statement that's not true is 3. The rocket was in the air approximately 6 seconds and then it hit the ground. Well, we know that's not true because after 6 seconds, it's still here in the air. Where we can agree that the rocket is launched from a height of 180 feet. We know that's just where it starts. We can also agree that the height of the rocket reaches its max after 3 seconds. 324 is the maximum height. And the rocket was above 300 feet for approximately 2 seconds. Well, 300 feet would be what? Starting here, then going here, okay, that's all together at least 3 seconds. So again, 3 is the least correct. All right, let's finish up page 1 by looking at the question. The height of the ball tossed into the air can be modeled by the function -4.9 x squared plus 6x plus 5. The question is, number 5 of the function represents what? Okay, take a couple seconds, talk with a buddy, pause the video. All right, welcome back. So if I bring your attention to these graphs down here, you'll see that, just based on me being able to do a little calculator work, uh, that I start with my x value at 0 and y is 5. So, what does that actually look like if you want to, utilize your calculator to a full advantage? Well, you put your equation in, as I probably could have done a little earlier. Now, once you've got your equation in there, what you want to do is you hit your graph, get a picture of it. Okay. So all I'm saying is my question is, what does the number 5 represent? Well, that number 5 represents its initial height. So I can, freely look at the graph and be able to come up to that conclusion. Okay, all right, so we're going to transition to the second page. Come on back for that video.